and chords. So we learned in the last section that a chord is a part of the circle that looks like this, so a line that goes through the circle. And an arc is a section of the circle. So like this would be an arc. This would be an arc. So first we have a central angle, so an angle whose vertex is in the center of the circle. So here our vertex is in the center. B is the center. So angle ABC would be a central angle. Next, we're going to look at the different types of arcs. So an arc is a broken part of the circle. A minor arc is an arc less than half the circle. A semicircle is half the circle, and a major arc is an arc greater than half the circle. So given that segment DC is the diameter, arc AC, so this arc here, since it's less than half the circle, it would be a minor arc. DAC, which would be this arc, is half the circle, so this would be a semicircle. And then arc ADC, so ADC, this arc here, is more than half the circle, so this would be a major arc. Okay, next we have the measure of an arc. The measure of an arc is equal to the measure of its central angle. So we can see here that AC has a central angle of 50, so the measure of arc AC is going to be 50 degrees. So it's the same thing as the central angle. Next we have arc CAD, which this would be half the circle. So the measure of arc CAD would be 180 degrees, because half of 360 is 180. And then we have the measure of arc ACD, so we go from A to C to D. So this part here would be 180, but we still have this 50 that's part of it too, so we're just going to add 180 plus 50. So this would give us an arc length of 230 degrees. Next we have adjacent arcs. So remember, adjacent means next to. So arcs that have exactly one point in common are adjacent arcs. So if we look here, arc QR and arc SR have this R in common, so they would be adjacent arcs because they're right next to each other. Alright, next we have a postulate, which is the arc addition postulate. It states the measures of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. So if we're looking at arc ABC here, arc ABC, this arc, the measure of arc ABC would just be the measure of arc AB plus the measure of arc BC. Okay, next we have congruent circles and arcs. So congruent circles are circles with equal radii. Congruent arcs are arcs that have the same measure and they are arcs of the same circle or of congruent circles. So in order for two arcs to be congruent, they either have to be arcs of the same circle. So we could have, let's say, an arc that was 30 degrees here and another one that was 30 degrees. These two arcs could be congruent. So this arc and this arc could be congruent. Or if we had two circles, let's say we had a circle and a circle, these circles have to have the same radii. So our radius would have to have some type of measure in order for our arcs to be congruent. So if this was 50 and this was 50, we would have to know that our radii would be the same in order for our arcs to be congruent. Okay, example 1. We need to name two minor arcs. So minor arcs we know are less than half the circle. So we could name AR as a minor arc, and we could name RC as a minor arc. Next, we need to name two major arcs. So a major arc is more than half the circle. So if we started at C, we could name this arc as CDR. Because CDR would be more than half the circle. Another major arc, if we started at R, we could name it RCA. So an arc can be named by either 2 points that it goes through or 3 points. But we wouldn't be able to name a major arc with just 2 points because we need to know what direction it's going in. So when naming it by 3 points, it's just telling us what direction we need to go in to make the arc. So we couldn't name this just CR because CR could be just this. So we need to know that it's CDR because we need to go this way around the circle. Okay, next we need to name two semicircles. So that could be CDA. So arc CDA and arc CRA. Part D, we need to name an acute central angle. So acute meaning that it's less than 90 degrees. So less than 90 degrees would be this angle ROA. So we're looking at angle ROA. Okay, and then E, we need to name two congruent arcs, which it doesn't give us any measurements here, but we do know the measure of a semicircle is 180. So two congruent arcs would just be the two semicircles that we named here. So we have arc CDA and arc CRA. So So our two semicircles would be our two congruent arcs, because these both have the measure of 180. So we need to give the measure of each angle or arc. So arc WX, so we're going to go from W to X. Looking at this circle, we know that this angle is 30 degrees. If this arc is 50, that would mean that this angle has to be 50 degrees also. And we know that all three of these angles are going to add up to 180 because it's a semicircle. So if we do, let's say, we'll call this X. So we have 30 plus X plus 50 is equal to 180. So 80 plus X is equal to 180. Subtract 80 from both sides, and we get X is equal to 100. So this angle here is 100. So that would make arc WX 100 degrees also. Because remember, our arcs have the same measure of the central angle. So WX is 100 degrees. Next, we need to find angle WOT. So WOT, we just found that doing the last one, so that is 50 degrees. And we knew that because our arc was 50, so that meant our angle had to be 50. Next, we need to find arc XYT. So start at X, go in the direction of Y, and we end at T. So we know that this half is 180, and this part is 30. So we just add those two together. So 180 plus 30 would give this an arc length of 210. So we have 210 degrees for our arc length. And our last one, angle YOT. So we go from Y to O, then to T. Since this is a straight line, we know that our angle measure is 180. Okay, so here we have some theorems. So in a circle or congruent circles, congruent central angles have congruent chords. So looking at this example, if these two angles are congruent, that would mean that this chord, ED, is congruent to chord CB. So congruent central angles have congruent chords. Our next theorem states that congruent chords have congruent arcs. So if we know that this chord is congruent to this one, then our arcs are going to be congruent to each other too. And then our third theorem states congruent arcs have congruent central angles. So if we knew that this arc is congruent to this arc, then this angle has to be congruent to this one. Okay, now we're going to apply some of those theorems. So we need to find each measure. So PT bisects angle RPS. We need to find the length of RT. So if PT, this segment here, bisects this angle, bisect means that it cuts it in half. So we have two congruent angles here. If our angles, our central angles, are congruent, that means our chords are congruent. So that would make 6x equal, so this chord is equal to this one, so 6x is equal to 20 minus 4x. And now we just solve for x. So we add 4x to both sides. So we have 10x is equal to 20, divide by 10, and x is equal to 2. It's asking us for RT, so we just need to take what we found for x and plug it back in. So we have 6 times 2, which gives us a chord length of 12. So RT is equal to 12. Okay, so we have 2 more theorems. In a circle, if a radius or diameter is perpendicular to a chord, then it bisects the chord and its arc. So here, our radius, which would be CD, is perpendicular, meaning that it has a 90-degree angle to a chord. So that would mean that CD cuts this chord in half. So ED would be congruent to DF. So these 2 segments would be congruent. In a circle, the perpendicular bisector of a chord is a radius or diameter. So here, if we have a perpendicular bisector, meaning that it cuts this in half and it's perpendicular, that would make this segment the diameter or the radius. So this is just saying JK is the perpendicular bisector of GH. So it's perpendicular and it cuts it in half. That means that JK is the diameter of circle A. Okay, so let's look at an example. So we need to find QR to the nearest length. So we're looking for this length here. So we know that this PS is our radius. What we can do here is draw another radius at PR. So our radius here is 10 plus 10, so it's 20. So this length here is going to be 20, because all of our radii are going to have the same length. So here we have a little right triangle. So now we can do Pythagorean theorem to find out what this length of our triangle is. So we can say 10 squared plus x squared is equal to our hypotenuse squared, which is 20 squared. So 100 plus x squared is equal to 400. We're going to subtract 100 here. So we have x squared is equal to 300. We're going to take the square root of both sides. So we have x is equal to the square root of 300, which we can simplify. So we can break this down into, let's say, 100 times 3. We can break it down more into 10 times 10 times 3. So since we have a pair of 10s, we can take out the 10, so we have 10 square root 3. So this length here is 10 square root 3. It's asking us for QR, so it's asking us for this whole length, but we know that this segment is congruent to this one. So we can just multiply 10 square root 3 times 2, because we have two segments that are the same length. So we're going to take 10 square root 3 and times it by 2, so we get 20 square root 3. And that's our final answer. So QR is equal to 20 square root 3. Any questions? You could put it in decimal, so you could find out what the square root of 300 is in decimal form, which would be like 11, that would be like 15 something. Actually, I think it would be like 17 point whatever, somewhere around there. And then you can just multiply that number times 2. Because it does say to the nearest tenth, so it would be asking for a decimal. But I just left it in the whole number. But you'd end up getting the same thing if we multiplied 20 times square root 3. But yeah, you can do it this way. Any other questions? Alright, if you guys have no other questions, don't forget that the notes are due. I think I made them due at 10:25, so you guys have a little bit of time to turn those in. But get them done now so you don't forget. Turn in those notes. And then there's a homework assignment due too. We're going to go over both the homework assignments, so 12.1 and 12.2 homework on Friday. So when I see you guys on Friday, we're going to go over all the homework. Any other questions? All right, you guys have a great day. I'll see you on Friday.